Hey everybody, welcome. It's Obi-Wan Pez for Encephalix Pachinko. We've had a fun time trying to move and get the office all together and all that stuff. I'm sitting on the floor. We just got notification today that our all of our furniture is on a boat which has made it out of Norfolk, I think, in Virginia. So no worries about the whole Baltimore bridge collapse issue. At least I don't think they were going out of Baltimore anyway. And then all of our stuff is headed to Netherlands, and then to Germany, and then to England. So that's why it's going to take a while. So I think for a while this is going to be my setup. Once I actually get a real desk, we'll actually figure out how to make this work. Because also it's not fitting. It's not fitting here, I don't think. We'll see how it goes. I was trying to figure out whether I should pull up all of the stapled down wire that's going along the running board, like all around the entire room. In fact, you can see some of it back here. It's going like basically, well, this one's going back beyond the fireplace there. You can see a gas fireplace just above my head here. That'll be remaining off for quite a while. But one of the connections is running basically directly in front of me, along this wall, out the door, around the corner, back through the other room, like behind this wall, and then about 3/4 the way in before it comes out again as a Cat 5 that was for the previous tenant's computer. I was like, I wonder if I could just pull up all of those individual staples and then run it from where the router is now all the way along the other side, all the way in the opposite side of the room, because kind of like that's where I want my stuff. Or maybe, I guess, along the like extreme back wall over there. That is a radiator that you can see back there, so not against the radiator, but you know. This is also not going to be my usual streaming time. It is currently 11:15, and I'm already pretty much conked out, but they got me on this like actual sleep schedule now. It's weird. But for now, got some tea, and for the most part, that'll be alright. Won't keep me up too long. It is certainly not coffee. So I've got more or less the same setup that I did before. I have my regular monitor here. The webcam is on top. I have my Windows box system set up on my left so that I can see stuff that's going on, and that is the Obi-Wan Pez handle that you see here. Hi, that's also me. And currently my monitor, the main monitor, is set up, somebody's gonna hate this, set up currently sitting on top of both of my desktop computers. So it's fine. It'll be fine as long as nobody comes terrassing in here. We're all right. All right. So I wanted to start off by taking a look at the fiddler on the proof. Now Zach probably did this weekend. So there would be no surprise that he probably knows it. Alright, this week on Fiddler and the Proof. You and a friend each have a standard deck with 52 cards. You thoroughly shuffle your deck while your friend thoroughly shuffles theirs. Then you both draw cards one at a time. If the first card you draw is the same as the first card your friend draws, you lose. Otherwise, draw again. If that card is the same as the next card your friend draws, you lose. Otherwise, draw again, yes, yes, etc. If the two of you can make it through the entire 52 card decks without drawing the same card at the same time, you both win. Otherwise, you both lose. So what is the probability that you and your friend will win this collaborative game? Okay. So if we think of your standard 52 card decks, you and your friend have shuffled thoroughly, so you don't know what is coming up next. There is no way that you are going to be able to stack the deck or anything like that. You just don't know what's going to happen. So, what do? Well, you flip one over. And your friend flips one over from their deck. And these are not equivalent to each other. So then we say, okay. Draw again. If, on the other hand, we do end up with 3 of diamonds and the 3 of diamonds, these are equivalent to each other, and so you lose. Okay, so what is the probability of this happening all the way through the entire deck of cards? So that one's going to be a little bit interesting. Okay, so the first card, the probability that the first card is the same is just going to be a 1 out of 52. Right, so no matter what card it is that you throw, there is a 1 in 52 chance that your partner will draw the exact same card. And then you end up losing. So, in order to succeed now, this is going to be a 51 out of 52 chance to succeed and not end up losing. Okay. So then, if we draw again, we both now have 51 cards. Okay, so this is also a very uncomfortable, like, sitting on the ground is very uncomfortable for me. My legs fall asleep all the time, so I'm gonna move a lot. Alright, so the chance of winning is gonna be 51 out of 52. The chance of winning the next one, again, your partner throws one of their 51 cards. The only chance so either okay, this is going to be a union. It's going to be either you throw one of the 50 cards that was not selected, or you throw the one card that was already selected. I think this is how this is going to work. So you can either throw, again, 50 out of the 51 cards that are left in your deck, or you throw the card that your opponent did on the last round. And again, you have a 1 in 52 chance of actually throwing that card. Or is it 51 now? It can't be 51, because if it's out of 51, then we're going to add those probabilities and then end up with 1. Just be 50 out of 51 or 1 out of 51. So in this case, okay. So this is going to be the first throw. On the second throw, get this. I kind of want to get rid of all this space over in the side of my window, but at the same time I don't know how to do that. Last time I tried to alter the stream compression and other stuff like that, and it kind of messed me up. I'm a little squashed, you can tell. Okay. Yep, that'll work. Alright, on the third throw, you have to throw 49 out of the 50 cards. Any one of the 49 of the 50 cards that are left in your deck that is not the one your opponent throws, or you would have to throw either one of the 2 that your opponent already threw. I think this is how this works. Oh man. So it'd also mean that up here, there's no other possibility because we haven't thrown any cards yet. Ugh. Okay. But then what if that card is already in... Oop, uh-oh. Good evening, everybody. Hey, Ian Stucky, how's it going? Welcome to The Simplex. So, my name is Obi-Wan Pez. This is N Simplex Pachinko. We're having some fun here. Good morning. You are, what, 6 hours back? So that's 5 p.m., 5:30, yeah? Alright. Life across the pond's doing alright. Think about winning the lottery with math. Yeah, it would actually be a lot easier, although illegal, to fix the lottery and make sure that you won. I don't recommend it. Why do you think I moved to England? No. I also have to redo all my affiliate paperwork. Yay! Because I moved countries. Hey, Braden Plays, how's it going? Real 200 ping. Everybody come on over from Ian Stucky's. I hope you had a really good time. Whenever I'm on their stream, it always just, you know, it either devolves into a wonderful time or or we do some wonderful math, so, or both. Great time. Nice. Stack exchange, yeah, yeah. Lie quotient, alright. Or Lee. I don't actually know. Everyone gets a slip of paper with a math problem that was so complex but has a couple digit solution. Was only available to students still in school, like Math Olympiad lettering. Yeah. I was looking at the Fiddler on the Proof that, again, I suspect that Zach probably did this, but wanted to poke around a little bit here, so. So the idea is that you and a friend start with 52 cards, one deck apiece, standard playing cards, and you both thoroughly shuffle so that you don't have any clue what's coming up next. Both you flip at once. Okay, good. Both you flip at once, and if it matches, you lose. Otherwise, you keep going. And then can you go through, or what is the probability that you will go through the entire deck and win with your colleague, your collaborative partner? So here, I was thinking about this, and I may be double counting, so I need to work on that just a little bit. That's why I was holding my head when you came in. Yep, I also missed Saturday's stream, but mostly because it started somewhere around like 4 p.m. So, man, everything's so messed up. So anyway, on the first draw, you both flip over your cards. There is a 1 in 52 chance that they will match each other, and then you lose. On the second flip, either... Well, I mean, basically, you can flip any of the cards that were not flipped yet. That your opponent has not flipped. That's not true. Save one. Right, so I said, okay, there are 51 cards in their hand, and either not quite. Okay. Either you have 50 of those cards are safe and one of them is not, or you flip the one card that they already flipped. So that pile over there is now one card. Okay, and this is trivial, but nonetheless, I like to do this just for me. And the 51 cards that are currently in your stack are perfectly valid and safe. Okay, and since that is just going to be 51 out of 51 is 1, then we're good. Right, we don't have to worry about that messing up our probabilities. Okay. So on the third flip, again, if it is still in their stack, then you have 49 out of those 50, which are safe. Or they've already flipped it, and it's 2 out of their possible 52. And all 50 in their hand would be safe in that case. I think this works. See how this degenerates very quickly. Okay, so on the fourth flip then, again, same deal. This is going to be, there are either 48 out of the 49 cards which are safe, or all of the cards in their hand are safe, and you can flip any of the 3 out of 52 that your opponent has already, or your partner has already flipped. This is cooperative. Yes, absolutely. I never actually posted the link to it, so... There we go. How's it going, Phobos? No problem. And thank you, Braden and Femvox, for the follows. I'll welcome you to the simplex. I did not know that one. There are also other fun patterns that exist within Pi. I don't know any of them really, but there are some really nice. There is at least one website where you can like search any string that you want, and it'll tell you the precise locations of those strings within the digits of Pi, as far as we know out, right? Like it'll search for, I don't know, the first 10 instances or something like that. And then if it finds, I can't remember. It's a text file, so like whatever. Or nah, it's gotta be faster than that. I don't even know. Some sort of database. Yeah. They allow it to run through and search for whatever string you input. So like you can put in your birthday, you can put in your phone number or whatever. I don't recommend any personal information, but you know, whatever string of numbers you can think of. Okay, so if I'm correct, this is going to be a sum of... No, this is going to be a product. Of the sum of two little things here. So we're going to go with... whatever flip we're on is going to go from 1 to 52. So we have to make all 52 flips. What is the probability that... Okay, so this is going to be 52 minus j over 52 plus j minus 1 over... No, that's not true, because it's not always 52. Okay. 52 minus j, it does get us all those things. Then we get at the bottom 52 minus j minus 1. Or in other words, 53 minus j. Yeah, 53 minus j. Plus, again, this is going to be a product with a form of 1, so it's not going to matter anyway. But j minus 1 over 52. I want to say that's right. All right. So this is not going to be convenient. We could do a sheets, right? Ew, why would you do that? Oh no, white screen incoming. Ah. Okay, so if we do this, we can do this as right flip number. Okay, just equals that thing plus 1. That was silly. Alright, so first one's going to be P of hand safe. P of drawn previously. The union, or their sum, and then running product. Alright, just because I like seeing stuff like this. Could be fun. Alright, so for P, probability of hand safe, we said that we want to take a quotient of this was 52 minus j over 53 minus j. Minus that. Divided by 53 minus A2. Whew. Yes, please. Control Enter to autofill. Woo! Alright, so we're going to take this, we're going to shrink down the number of decimals that we have here. Alright, good enough. Probability of drawn previously was, one more time, j minus 1 over 52, I think. A2 minus 1. Control Enter. Right, so on the first one there is no drawn option. So that makes sense. Oops. There we go. I think we're probably okay with that one just being 0. Just cuz. Take the sum of those two things. So this is going to be B2 plus C plus C2. Control Enter. Oops. Nope. That is not the case. I mean, I should have seen it coming, really. Okay, so this needs to be fixed, obviously. Right, the last one's going to be... Second to last draw is a 50-50 if it's still in their hand. And if it's not in their hand... There's a 96% chance it is not in their hand. If you make it to 51... yeah. If you make it to 51. And then 51 out of 52 is going to be that last one, the 98%. Is just, again, the chance that you... It's the exact same, right? 98076, 923, yeah. So that's the chance that the one card you have at the end is identical to the whatever your opponent has. Alright, so clearly this does not work. Alright, now we have to go back to the drawing board and say, why not? So, can't just do addition here. Hey, Brendan. Phobos, yeah. I mean, like, if you know the answer, probably don't just give it out, but... So generally speaking, like, as we're approaching the problem, right? You're going to look at this and you're going to say, okay, what's the probability that this thing... This is the probability that it is in hand. Probability that the next card is safe and in the deck. All right, or this one here is going to be the probability that the next card is safe because your partner already drew it. Possible. So... Right, because it doesn't matter what you call them. It's just a one-to-one correspondence. yes. I'm going to say yes, that is the identical problem. So probability that... number of permutations of 52. Hey, Oak Spirit. Yeah. If you're talking about a critical point with purely imaginary eigenvalues, then it is, if it's a linear differential equation, then it is 100% stable, because it is going to only, once it is in the locus of control, see, nonlinear. I was thinking once it's within like a specific area, then it's going to be just circling it. So there's not going to be, like, it's not going to go in, it's not going to go out. It's going to always keep out of a certain distance. So I was talking with Ian Stuckey toward the end of that stream there. I was way in the background. But we did Jacobi linearization, and when you linearize that particular around any critical point, you can linearize the system and say it's going to be close enough to a linear system when you get close to that critical point, because the eigenvalue, it's essentially like talking about zeros of a polynomial. When you get really close to the zero, none of the other stuff really matters, and you can just consider it a constant, essentially. Like the zero of the polynomial takes over the behavior and brings it to zero. And then you can determine based on the multiplicity what its local behavior is going to be. You could do the same thing for differential equations. So we're just saying, okay, in a linearized system, the behavior around this critical point is going to behave as if, or very similar to, but technically legally distinct from, the nonlinear system. So linear and nonlinear, really, really close to a critical point, is practically identical. Yep. Yep, any purely imaginary eigenvalues, it will be circling that critical point and never actually doing anything with it. That's essentially going to, come on, there we go. So, you know, you've got something that looks like this. Yeah, it's not very likely. It's going to most likely stay close to that one. It's still possible that it could swing back out again, but it's going to be difficult based on, you know, whatever local behaviors you have going on out here. It could be other cool stuff. Nah, I don't have one. At least it's not public yet. I'm thinking about it, but we're getting there. But if you do know the rest of the math chads we have here, We have Don Does Math. We have e to the 2 pi. That's uh, our friend Zach, who ran the real analysis. There we go. Real analysis course that a bunch of us took over the summer, or no, over the winter. A number of us have already taken real analysis, but it was really good to like familiarize ourselves with slightly different ways of doing it and re-familiarize ourselves with the mathematics, because it's been like 15 years essentially since I did real analysis. Sure, if you want to go to Penn Centers, I have that one somewhere. Oh, of course you want to update. Okay. You probably already have it, but just in case. So I don't technically know the definition of Lyapunov stability, but there we go. Can be extended to infinite dimension manifolds. Very nice. Okay, equilibrium state x star of a dynamical system is Lyapunov stable if all trajectories of the system starting from a neighborhood of x star stay within the neighborhood forever. So yeah, you can determine a neighborhood for which it is stable, then it is going to be Lyapunov stable, looks like. So in the example that I have here, for example, that's, yeah, I can word. So if the next trajectory comes off like this, and then they go off and do something weird here and here, then what I'm going to assume is that everything within this trajectory, let's say that this is the border region, of that critical point. Okay, so all of this should be Lyapunov stable. I'm not entirely sure if there's a specific way that this definition is allowed to be applied. If you want to say, no, it has to be a neighborhood. We did this sometimes in real analysis. One of the ways you might be able to do it is kind of like measure out to the border in multiple different directions. And then say we're going to take the minimum value of that, which is going to be probably here. And then we draw a circle. It's totally a circle. And you say, like, this is the minimal neighborhood for which it is Lyapunov stable, and therefore, you know, because it's a circle, It's a neighborhood that's entirely within. This is, hang on, let's see. This is the largest circle that you could draw, which is entirely within the region of stability. So I don't know how that works exactly, but that's what I'm going with. Either it's going to be the entire region which just has stability, or it's going to be here you have a certain radius, the minimal distance to the border, and then that circular neighborhood. And then in higher dimensions, it's going to be, n-dimensional sphere of stability. Yeah, I feel like it makes sense too, but your teacher may have other ideas. So, I mean, I have studied differential equations up through nonlinear and partial, so I probably talked about this at some point. We'll see how it goes. Have you taken real analysis or like advanced calculus or something like that? And by that I do mean, talking about neighborhoods and what does it really mean to be like within a particular neighborhood. Calc 1, Calc 2, and discrete. Okay. So yeah, not so much. Woo. Yeah, nice. Yeah, I definitely see what you mean here. So, if we take this, yeah, this is the one you were working on yesterday, 2 days ago, whatever it was. Image downloads? No. Picture screenshot. There we go. 5.2. Yeah. So I feel like for this particular picture, you're going to have again, the Lyapunov stability can either end up being just everything within this sort of elliptical region-ish, and actually it's probably more like two polynomials stuck together like a lemon sort of shape. It's like round this way and round that way, but they have cusps on the end. Or, that's my orange solution, or we're going to say, okay, this is going to be measured up like that, and then this is just going to be a circle that comes in like that. Yeah, it looks like an eye. Might be sort of creepy. Yeah, I mean, sometimes it's actually preparing you or other students for the next several classes, and sometimes more explicitly than others. Because I know several of my professors in college were like, their knowledge is just so high, and they don't know how to speak to students who don't have that knowledge. It's one of the reasons I kind of like doing community college. It's just that, like, you could have a much more accessible like range of students, as well as your range of knowledge typically is a little bit more accessible to the students as well. My my daughter was complaining today that I always make everything too hard. So I was trying to talk about she's trying to do an assignment that was I mean, like, super simple, but something like this. I can't remember exactly what the numbers were, but it was like, the Roman Empire was formed somewhere around 280 BCE, truly founded, and then went until 410 CE, and like, yeah, it was what was the span of the Roman Empire? Like, how long did it last? And she was just like, ugh, this is just so hard. I'm like, oh man. I'm trying to, like, get everything kind of focused in, like, this is practically trivial, but I know that it's hard for you. So I was like, remember, all the strategies you learned in the United States. What do you think you should do? And she was like, all right, you got 280 BCE over here and 410 CE over there. And I was trying to tell her, like, trying to hint at, and this is her problem, is that she doesn't, I don't, like, give her the answer. Or like, what is the one thing you're looking for? That's it. She was like, well, I should add them. Like, add the numbers together. And I'm like, all right, fine, why? And it's just like, like, why should I have to add them together? That's ridiculous. And I'm just like, it's the, why would I have to explain this? I'm like, no. It makes sense once you actually, like, think about it and work into it. So eventually she was like, okay, well, I said, okay, what if we look at this year, and I said, how long has it been? She was like, well, you can start here and then start counting up. And I'm like, okay, it's one way to go. What else? And eventually, oh, she just wrote on the paper, that, and I was like, why'd you do that? She's like, I'm just trying to find out, like, how far apart they are, how, what's the difference between these two numbers. And I was like, okay, so we could probably generalize this. And she was just like, oh. You always make everything so complicated. I'm like, no. Said, okay, so with these numbers, you want to do the same thing. What are we looking for? What? And she was like, well, we got, 0 in here, so we counted these up and we counted these down, so this is 280 and this is 410, so we should just add these numbers up. And I'm like, okay, that's how you do that if you're thinking about it in terms of plus. Now let's think about it in terms of minus. What were you doing? Oh, we're looking for the difference between the two numbers. What does this difference represent? And it took her a minute, and I had to kind of say, okay, well, you're saying how far apart these things are. And she's like, oh, it's a length. I'm like, great. What's a length? Measurement? I'm like, what kind of measurement? But that's kind of the whole point, is that difference is going to be equivalent to distance in many contexts. Not always, but Yeah, just wait until we figure out, wait until we work on absolute value. It's gonna blow our mind. But yeah, eventually we're like, oh, well, this can be translated into being a negative, and then we do, you know, 410 minus negative 280, and she goes, oh, minus minus. It's a plus. I was like, yeah, there we go. I mean, she's already starting in, like, there was some algebra incorporated into fifth grade math in the United States. Some, not like a lot, but, you know, like fill in the blank sort of things where it's like, 10 minus x equals 5. What's x? And that sort of stuff. But then there was starting to be like, well, we're going to add these two numbers together. What would happen if you get like 10 minus x plus 3x minus 4? What would happen with this? She was getting all freaked out at one point, and I'm like, okay, well, what were the things that you were taught about in the last several years? And some of it was like, oh, well, I'm allowed to move these things. Okay, why is that? We got back into the commutative law and all this stuff, which, by the way, they taught my son in second grade when I was sitting in on that class. They were talking about how they already knew the law of commutativity. I was like, ooh, all right then. All right, I'm going to take a quick break here to go out and, do whatever I need. And I'll see you in 3 minutes. We'll do 3 minutes. All right, hang on just for a little bit. Yeah, that's one of the problems with exams. Really coming up with appropriate exam questions is always like one of the hardest things for me. I hate doing it. But during fall semester, I'd actually set it up so that I was doing this new, I didn't bring it. It's all downstairs. I was doing a bunch of stuff with Peter Liljedahl. Did some like K-12 work and attempted to make K-12 mathematics more approachable within the well, he is Canadian, so within the frame of Canada, but a bunch of American teachers have also like picked up on what he's trying to do and try to do some cool stuff with it. I was like, oh yeah, let's try this, and I rewrote my curriculum. Well, I rewrote Monday's lesson on Thursday in the session where he was talking about it. I was like, no, fuck it, we're just changing everything. So that was 2021, 2022. If the exam is written correctly, then like having some amount of notes or anything like that will not make any difference whatsoever. So if you write it properly, then the students who like know how to work with the material and have practiced enough, like never need any, practically any sort of cheat sheet technology, whatever. They'll just be able to know how to set it up and how to get it done. They'll know about the algebraic manipulation. They'll know how to do all this other stuff. Yeah. And like, even if somebody didn't know how to get this specific one, seeing their thought process and like having them be able to explain it out would actually do just a world of good. Yeah. We have a candy shop in town, and I found honey licorice. It is weird. Actually, I think this originally came from a town in Yorkshire that everybody's like, you have to go see this place. The roads are exactly 1.6 vehicles wide. Like you can, or they are 2.0 vehicles wide. Like you can get 2 cars by each other, barely. But it was wild when the SUV comes this way, and I'm like, oh no, that's not cool. And there's a parked car on. Anyway, the town boasts the oldest candy shop in the world, I think, or like continuously running oldest candy shop in the world, or something like that. It was like the 1800s when they started. I feel like there must be an older one somewhere, but at the same time, it's like, this is the only one that actually continued running the entire time. It's pretty cool. They also have a hot chocolate cafe where, and yeah, you can get coffee, I guess, where they take bricks of chocolate that come from various places around the world, and like you can make your own mix. And they take cheese graters and just like shave off a whole bunch and melt it in your cup, and maybe put a little bit of water in it and milk and whatever else, and there you go. You have a hot chocolate. They were like, do you want to try any of these chocolates? And they point to a big like world map, and there's 20 different places, and they're like, absolutely, just any of them. Even if you want to try one from every place in the entire world, you are welcome to do that. And we're just like, that's a lot of chocolate. But there was like dark milk and white chocolate from, a dark from Ecuador, and another one from somewhere in Africa, and a white chocolate from like Sweden, and so I had to make a mocha for me. They made hot chocolate for each of my kids and for my spouse, and it was just like unbelievably good. Hey, Zach. Yes, thank you. It's only 12:30. So hey, Treasure Mango. I have taught in a classroom setting in Maryland in the United States. Anywhere from basic algebra all the way up through differential equations. On this particular site, we also just try to help people in wherever they are. So there's a bunch of there's a bunch of stuff that I'm no expert on, but I can at least try. But like I said, have taught everything with those two endpoints. I guess technically, with the exception of I have not taught statistics, I have not taught multivariate calculus, and I have not taught linear algebra. But that being said, right, I have taught probably all of the individual objectives for all of the courses, with those few exceptions. Linear algebra and multivariate calculus, I taught as a part of differential equations in some way, shape, or form. And statistics I've been getting better at. The probability side is nice and easy, but yeah, the doing t-tests and chi-tests and stuff like that, like all right, got another one in there. Ooh. Okay. Oops. Nope, that one. Yep, and Zach, we were looking at the who's it's Fiddler on the Proof for this week. Found a dead end. So I gotta work a bit harder. See if I can get it. Yep, I don't know if you looked at this week's, but pretty interesting. Alright, so this is y double prime minus 4 over t y prime 6 over t squared y going to be equal to t. Regular y of 1 is going to be 0, and y prime at 1 is going to be 1. Yeah, no worries. Alright. Now, me personally, I'd probably do a series, infinite series on these. There's probably multiple other ways to do it. Euler equation? Okay. I'm wondering if I never actually explicitly studied one of those. I mean, maybe like one, but... Okay, so y of t is going to be t to the r. Alright, so y prime is going to be r t to the r minus 1. And y double prime at t is going to be r squared. Nope. I mean, you could have r squared, but r minus 1, t to the r minus 2. Maybe, but I haven't done it yet, so this is one way to make sure that I'm doing all the right steps. Because quite frankly, I wouldn't want to rely 100% on my brain. Alright, so y double prime is going to be r minus 1 to the r minus 2. Okay, minus 4 over t times y prime is r t to the r minus 1. Oh yeah, this is going to be nice, because you'll notice here, right, the t here and the t here. I'm going to bring that back down a level. Plus 6 over t squared times t to the r. Hopefully all that stuff is equal to t at the end. So we can not bother with that for the moment, and then just say, okay, all of this is going to end up being excellent. Good placement. So yeah, now we can expand this out. We get r squared minus r t to the r minus 2 minus 4r t to the r minus 2, because here we have t to the r minus 1, but then we're taking it down 1 with a t to the minus 1 there. Plus 6, and again here we have t to the negative second, and then we're multiplying by t to the r, so this is going to just be 6 t to the r minus 2 is equal to, nope, is equal to just t. the r minus 2 on the outside. That's going to leave us with r squared minus r minus 4r plus 6 is equal to t. Knock those over there. This is going to be r squared minus 5r plus 6. Very nice. Is equal to t to the 2 minus... That was not it. Okay, so it's divide by r minus 2 negate. It's going to be r... Wow. 2 minus r plus 1. So 3 minus r. Now, this might just be do a homogeneous equation first, like we always used to do. Yeah. Okay, so this factors nicely into r minus. These have to have the same signs, and the bigger one is negative, so both of them individually are negative. R minus 2, R minus 3 is equal to, again, if we go with homogeneous solution, So if we make this the homogeneous solution, we can find the particular later. So that also means that all these t's are now just going to be zeros for now. I don't like doing it, but 0, 0, 0, 0, and 0. R is going to be equal to either 2 or 3. Again, this is characteristic equation. Two is going to be trivial. Alright, so 3 is actually going to be the more interesting one. So then y homogeneous of t is going to be equal to t to the r is going to be third power. Or are they just going to be linear combinations of the two? Yep, they're going to be linear combinations of the two. Alright. So, fundamental set of solutions. Never mind. Not trivial. Slanderous talk. Alright, Alright, so we have our homogeneous solution, which means that this is going to be 0, and then our particular solution is going to have to be something with t. So what I have on Euler form is that the solutions are of the form, in this case, t to the r. So unlike way back when we were doing, right, solutions that needed to have its derivatives as e to a power, exponentials. In this case, we're saying that they're going to be polynomials. So this is of the form yeah, so this is of a polynomial form. So we say, like, where do we start with it, basically? What values are going to get us something useful? Alright, so then the particular, right? If it's... Okay, so if it were just t, right, 2 and 3 are going to get us 0. So exponents of 2 and 3 are going to get us 0 for this whole thing. So it doesn't even matter. Those are just gone because they're homogeneous solutions. So for the inhomogeneous, I guess nobody calls it heterogeneous, inhomogeneous solution, or for the non-homogeneous solution, we need some function that has a t in it. It's probably going to still be a polynomial. And it can't just be t. Because if it's just t, right, then our second derivative would end up being 0. Our first derivative is 1, and then we've got over t. And then this would be 0. So 1 over t is not going to be equal to t, so t to the first is not going to work for us. So I'm going to accelerate that up and say, okay, let's assume that it starts with t to the fourth. And that's not going to work, is it? Oi. So the t squared portion is going to end up just being part of the homogeneous solution, so it's going to get wiped out. That's aggravating. So like I would have said we would need this to be t to the third, so that we could have a t to the third divided by t squared to get us a t. Right. Because, like we said down below, any amount of t squareds or t to the thirds are just going to end up wiping out to become 0, no matter what the constants are out front. So just adding some more constants isn't going to help us. This becomes an interesting quandary. But we could also just experiment here and say, okay, look, I know that this is not going to work, or at least part of this is not going to work, but let's just try it because. So if we say y sub p of t is going to be, right, a t to the fourth plus b t cubed plus c t squared plus dt plus e. Yes, that is humongous, and no, I'm not going to apologize. Right, this is just to prove that it's not really going to help us any. that there's always going to be some little portion that's going to be an issue. Okay, so y prime is going to be 4at cubed plus 3 bt squared plus 2 ct plus d. Y double prime is going to be 12at squared plus 6bt plus 2c. Alright, now if we do this, this is going to be the 12a t squared plus 6bt plus 2c, matching with the stuff from, we won't do that yet, minus 4 over t times 4at cubed plus 3 bt squared plus 2ct plus d plus 6 over t squared times a t to the 4th plus bt cubed plus c t squared plus dt plus e has to be equal to t. Sine or e or something? No. So the problem with that is that if you do add one of those other types of functions, they're not in the particular portion. There is the possibility of taking a derivative of, say, like a natural log, and it ends up becoming polynomial. So, in theory, there's something that might occur with that, but the fact that we have natural log of 0, or that we would have y of 0 and y prime of 1 as like two of our initial conditions tends to rule out a lot of weird stuff. So if we're like, well, it's a natural log, right? Then we've got a 0 in there, so you might be able to play around and find something, but okay. So 12 at squared minus 16 at squared from the first block of the second term, and then the first block of the third term, we get another plus 6a t squared. Okay, all of that has to equal 0 t squareds. So basically what we're doing is we're just taking this equation here and we're saying that all of the individual parts need to be the same on both sides. So all of the stuff that has t squareds needs to have the same coefficient on the left and the right. So, right, we've got all this stuff on the left, 12 at squared minus 16 at squared plus 6 at squared, and on the right we have 0 t squared. So I think a has to be 0. But hey, gotta prove it. So here this is going to be a negative 18 minus 16 is going to be 2 at squared. And A then has to be 0 because none of the other things can always be 0. Implies A is equal to 0. Right, so linear 6bt minus the stuff with b's is going to be negative 4 times 3 is going to be negative 12 b, and t squared over t is going to be t. The b's on the next one are going to be 6b t cubed over t squared is going to be plus 6 t. B, t. Yeah. Equals t. Now we've got a problem. So this is telling us that 0 bt needs to be equal to 1t. So that's going to tell us that t has to be 0. And I don't like it. So at this point, we just say that there's a faulty assumption for all this stuff. And then it has to go away. It is also possible that this question is broken, but I would start with, like I said, we're looking at, well, we know it's part of the homogeneous solution. So our, bt squared thing can't be part of it. Or bt cubed from the beginning and ct squared from the beginning can't be part of it. Das hoist. Thank you, Y83916F. Must be otherwise. I do not personally have a Discord. However, we do use the Elements Discord, which is a number of math streamers. Because there are actually more of us than just me. What? Many of you are also from other places. And came here because you follow other cool people for some definition of cool. The best one. Oh, I don't have one. That was weird. From Danny Highway? Yep, nice. Well, that makes an interesting point. Yeah, I don't know exactly how you go about doing that one in particular. Hang on. Give me 1 minute here. I'm going to go check on something real quick. Strange sounds in the house. Anyway. Leo, there is the possibility that they want you to do something like variation of parameters with it, where it's like you have a solution, it's t squared, then what you should do is assume that your second solution is going to be t squared times some sort of function. Linearly independent solution, yeah. Mm-hmm. Yep, must be otherwise go for, you can either put it in Penn Center's Discord, which is the one that I gave you there, under the Maths chat or the Maths forum. Take your pick, and should be able to get to it in just a couple minutes. If anybody has any other questions, feel free to also drop them in the same Discord there. Right, so if y1 t was t squared, and we were looking for, again, y double prime minus 4 over t times y prime plus 6 over t squared y is equal to 0 for the linearly independent. Then y2 of t is going to be equal to u times t squared, where u is a function of t. So y2 prime is going to be equal to u prime times t squared plus u times 2t. Y2 double prime is going to be u double prime. There's a shortcut, isn't there? Times t squared plus right, u prime 2t plus from this one u prime 2t plus from this one u times 2. Right, so u double prime t squared plus 4 u prime t plus 2u. Really should have that the other way, whatever, it's fine. Hey, Sensation. Yeah. Nah, no worries. Lurk anytime you feel like it. Come and go as you please. We're very lax here. Rules. All right. Rectangular garden area 832 square feet, much better. to be surrounded on 3 sides by a brick wall. It's costing $8 per linear foot. And on one side a fence. Ooh. And on one side, and on 3 sides, no, man. 3 sides is the brick wall, $8 per foot, and one side the fence costing $5 per foot. 2 sides of equal length will consist of brick. Other 2 will have one of brick and one of fence. Sure. Find the dimensions of the garden such that the cost of the materials is minimized. Nice. Yep. Yep, so one of the things you pretty much always do with those kinds of things is you look for an objective equation. In this case, your objective equation is the cost of the materials. So if you can build out what is the cost of the material going to be and just input variables for the things you don't know, then this ends up being a fairly simple like Algebra 2 question. I mean, realistically, some people could teach it in Algebra 1. But the way my students were going, it was definitely Algebra 2. And we'll come back to it in a couple minutes. Yeah, once you check out that video and I finish up a little bit with this one, we'll see where we end up. So it's not... That is just y2 prime, or double prime. That's not all of it together. We would need to then combine all of it and say, okay, we're going to take t squared u double prime plus 4t u prime plus 2u subtract 4 over t times y2 prime, which would... I need to be consistent here. T squared times u prime plus 2tu plus 6 over t squared times t squared u is then equal to 0. Okay, so we'll move. Right, so t squared, u double prime, no other double primes anywhere else. Cool. Get the primes together, so this is going to be 4t. Here, this is going to end up being minus 4. T squared over t is just 4t u prime. So this is going to be minus 4t. So that part is just going to be gone. And I believe that's actually expected. That some of this stuff ends up canceling out very nicely, and that's just the way it is. And then here, we end up with a negative 4 times 2 is negative 8, times t over t is just now going to be u. So negative 8u. Oops. Forgot. This was u prime. Okay, so minus 8u plus 2u from up here and then here this is going to be a plus 6u. So this is 8u, this is negative 8u, those are all gone now. Right, equals 0. This is all 0. So now we just get t squared u double prime is equal to 0. So u double prime is equal to 0. Which means that u prime is going to be just a constant. And u is then going to be ct plus d, linear. And since a linear times y1 is just going to be y1, the d can just go away. So we end up with u is going to be equal to ct. So y1 of t is going to be t squared. And y2 of t is going to end up being c times t squared. It's t cubed. And again, the homogeneous solution then, because of all that we figured out here, was going to be c1 t squared plus c2 t cubed, right? Linear combination of those things. So I think this means that the t cubed that we want to have in the original equation is only going to be homogeneous, and therefore I don't think that there is a solution such that the non-homogeneous portion is t. I don't think it works. I wouldn't say trick question, but you know. Okay. So this is going to be $5 per foot. These three sides here are going to be $8 per foot. Yeah, I think the third problem is just going to not work. Like, I don't think you can get a solution such that the non-homogeneous portion is t. Because you'd need to have t cubed in order to get knocked down by 2 degrees. And it doesn't work if you plug in t, just t. Right, because you get fractional stuff. So there's a problem with that, and that is that they're not going to be just a straight linear average, because you're not using the same amount of material for each of them. It's a weighted average. So you've got to determine what the weighting would be in terms of like how much more is going to be used on the top and bottom than on the sides. But for our purposes, it's not working, right? You could say that the horizontal portions have an average cost of $6.50. And the vertical cost have an average, or the vertical portions have an average cost of $8 per foot. Yeah, okay, yep. Yeah, because it's rectangular, those two portions have to be the same distance. Yep. You could also prove that using the other part of this, which would have been like, okay, let's get our cost function. And so what is cost? Well, cost is going to be the amount of stuff multiplied by the unit price. So if you do the usual width and length thing, right, then yeah, you end up with, okay, this is going to be 2W is going to be the amount that we're using. We're going to get a W there and a W there. And then we're going to multiply by the unit price, which was 8. And then also the top and bottom, which again is going to be 2L. Well, no, let's not do that. We're going to get one of them as L times 8. And we're also going to get one as L times 5. Okay, so this is going to be equal to our C cost function. So the total cost is going to be 16W plus 13L. Alright, I'm going to look at problem 2 for you there and figure out why exactly there's a natural log in it. Oh. Natural log of t or natural log of... Yeah, natural log of t. Okay. With the cost function being 16W plus 13L. We wanted to minimize the cost. That's linear. Question, was there another constraint? Ah, 832 square feet, yes. Area, 832, which is equal to length times width. Yep. So what you're going to be looking at here is saying, okay, we're going to have this cost function. It's going to be our y variable, and then we can take this relationship that we know and find some way to make this a relationship in one variable to another variable c. So take your pick. Do you want to keep L or keep W? And then the other one is going to be 832 divided by whichever one you want to keep around. So if you want to get rid of L, make it in terms of W. Yeah. So C is going to be equal to 16W plus 13, L is no more, 832 over W. Oof. What do you mean you guess? No, it definitely got an equation. Ah, yep, okay. Variation of parameters is probably the way to go with that one then. So once you find the homogeneous solution, to find the particular solution, you replace the constants in here. Y particular of t is equal to u t squared plus v t cubed, where u and v are functions of t itself. Alright, and then go from there. I think that'd do it. So you can't exactly solve for W as it is. Have you done calculus? Taking calc now. Yeah. So how would you find the minimum? Yep. Just want to make sure it wasn't for pre-calc, because like if it's for pre-calc, generally speaking, it's like, okay, now plug it into the calculator, let it find the minimum. Yeah. So take the derivative and then do what? Because I'm a jerk like that. Yeah, there you go. So yeah, take the derivative of this stuff, set it equal to 0, and solve for W. I'm kind of curious if I can do it an alternate way here. I'm going to multiply through by W. Madman, what is this? Well, never mind. C prime needed to be 0 anyway, so this doesn't need to be here. C equals 32W. Yeah, that's perhaps unhelpful. 2 squared to 13? Seems right. Let's see. This would have been 16W over 32 is 1/2 W plus 13 times 13 over 32 times 832 over W. Oh, that's gonna be nasty. And we multiply through by W again. So W squared is equal to 1/2 W squared plus this stuff. 32 into 832. How many will go nicely? GCF 32 and 832. It's 32. Okay, cool. $26. 26 times 13 is 169 times 2 is 338. So W squared minus 1/2 W squared is going to be 1/2 W squared. Plus 338 is going to be W squared, oops, equals, man. It's going to be 676. So W is the square root of that. Which, if you're saying that it is 2 2 square roots of 13, then we can take 676 divided by 13. We should get 52. Interesting. Okay. Oh, 676 divided. Take the square root, it is 26. Alright, that's gonna be feet. So, not 2 square roots of 13, unless I really screwed up, but... it's possible I double counted something. I was just seeing if I could set it up slightly different, which of course is... I got rid of the fraction first. That really messes with stuff. Got rid of the constant entirely, but then we had to bring it back through the process. Alright, let's do it for real. Alright, so C is equal to 16W plus 13 times 832 gross. $10,816 over W. We take the derivative of both. We end up with C prime is equal to 0, which is 16 minus 10,816 over W squared. Bring that to the other side. This is now going to be 16W squared is equal to that 10,816. 10,816 divided by 16 is 676. Okay. So actually, I was right. So it looks like you're off by a factor of 2 somewhere. Good news, that's a simple mistake, and probably pretty easy to figure out where. But yeah, W is going to be 26 then. There's something with variation of parameters which we were able to make it much shorter. I think we just let the sum of the two yeah, we let the u prime plus v prime term just be equal to 0. So that's this and that, which are gone. We're just left with 2tu plus 3t squared v. Then for the double prime, we don't make any assumptions. We actually go through with the product rule. So this is going to end up being 2u plus 2tu prime plus 6tv plus 3t squared v prime. Alright, so that becomes 2u plus 6tv plus 2tu prime plus 3t squared v prime minus 4 over t times the new y prime, which is t squared u prime plus t cubed v prime. Nope. Other one. The other one. The one that's not 0. 2tu plus 3t squared v. There we go. Plus 6 over t squared times u t squared u plus t to the cube v is equal to t. Okay, 2 plus 16 squared v prime minus 8u minus 12t v plus, we'll just go down, continue, plus 6u plus 6tv, all that is equal to t. Alright. 6tv, 6tv, and minus 12tv are all going to be 0. Uh, 6u, 2u, and negative 8u are all gone. And now we have 2t u prime plus 3t squared v prime is equal to t, and we can couple it with the equation we said earlier, which is right there, t squared u prime plus t cubed v prime is equal to 0. And now this is a system of nonlinear equations. No. So we're on a different part. we're talking cross purposes here. This method here, using variation of parameters, is to figure out the particular solution given the homogeneous solution. So if you already have the homogeneous solution, how do you find a particular solution? And so that's what we're doing here. If this is equal to t as a whole equation, then we're saying, okay, it's going to be set up such that this is equal to the particular solution, just t in this case. If it's just equal to 0, like if the differential equation is just equal to 0, then all you're doing is trying to find the homogeneous solution. Your individual, what was it, the initial value problem that you were trying to work out, just is trying to figure out what C1 and C2 are. Yeah. Okay, so from here, we could say we need to do this just as if it were a system of equations from early algebra. So we're going to multiply the top equation by t and the bottom equation by -2. And this is now going to get us something that will cancel out in u prime. So here, we're going to get 2t squared u prime and -2t squared u prime, so that's 0 coming down, plus 3t cubed v prime, oops, minus 2 t cubed v prime is equal to t squared minus 0, so just t squared. So now this is 3t cubed v prime minus 2 of them, so 1 v prime is equal to t squared, Therefore, really? Oh, no, wait, this is V. This is fine. This is fine. I'm good. Alright, so V is then going to be T cubed plus C, but none of that's going to matter, right? Because again, it'll just give us the homogeneous solution again. Then we have to plug V prime back in to second equation. Sure. And technically 1/3, but again, this is going to be put into a place where it's not going to matter. Second equation, t squared u prime plus t cubed v prime is t squared is equal to 0. This is t to the 5th plus t squared u prime. U prime is equal to negative t to the 5th over t squared is going to be t to the 3rd. So it's a negative t to the 3rd. Interesting. Again, that's not going to matter, so it's just t to the 3rd. Oh, that's prime. Then u is going to end up being a negative 1/4 t to the 4th. Denny Highway, how's it going? Okay, so now we've got that, you know what, let's just use the constants the whole way through. So y particular of t is going to now be a negative 1/4 t to the 4th multiplied by our u was paired up with t squared. Okay, and then plus we get a 1/3 t cubed for v times t cubed for our second homogeneous solution, which is now going to get us a negative 1/4 t to the 6th plus a positive 1/3 t to the 6th. A third minus a fourth is going to be 1/12 t to the 6th. Goodness. Oh, I've been alright, Danny, thank you. Trying to get this all set up here, which is such an illustrious set. I am sitting on the floor and my legs are falling asleep, so this is fun. We did... knees. We did receive word that our shipment is has left Norfolk, Virginia, and is heading toward Netherlands. It'll get into Antwerp, probably in like a week or two or something like that. And then it'll head out to Germany and then get trucked into England. We're like, man, I guess that's how ports work. Can't just stop off at Portsmouth and drop that off and yeah. Okay, so Oak Spirit, this means that there we go. Now I can actually like be up here. Let's go like that. Alright, so this means that our total solution y of t is going to be c1 t squared plus c2 t cubed plus 1/12 t to the 6th. And that will mean that then we can look at what our original problem was, wherever the hell I left it. Here we go. Y at 1 is 0, y prime at 1 is 1. Alright, good news, it is a polynomial, so makes it easy. Alright, so y1 is 1, y prime at 1 is 0, y at 1 is just going to be c1 plus c2 plus 1/12. It's going to equal 1. And this is going to be 2 c1 plus 3 c2 plus 6/12 is 1/2 is equal to 0. Or in other words, right, c1 plus c2 is going to be equal to 11/12. And 2c1 plus 3c2 is going to be equal to negative 1/2. Just like we did up there, figure out whatever you feel like. Alright, multiply the first one by -2, the second one by 1. Good enough. Third page notebook paper, yep, that's pretty common. You're gonna have to get used to it at this point. Alright, so then this is gonna be -2c1 minus 2c2 is equal to a -11/6. And 2c1 plus 3c2 is going to be equal to -1/2. Good news, right? Almost done. This is just going to be c2 is equal to -3/6 is going to make this a -14/6 or a -7/3. And then c1 is going to be equal to was it negative? Crap. 11/12. So that's going to be, man, always just move it slightly out of range. C1 is 11/12. Minus negative makes a plus 7/3. So it's 28 plus 11 is 39. Allegedly? Whoa, no. Yes, okay, times 4, yeah. So y, nope. I'm standing up. Y is going to be equal to, this was 39/12 t squared. C2 is negative 7/3 t cubed and plus a half t to the 6. Was that right? No, 1/12. Boop. There we go. Yeah. So yeah, our chair isn't gonna make it in. The desk is also not gonna make it in until like June. Okay, so then the moment of truth comes because now you've actually got to check it. The good news is you just plug it into Wolfram and make sure it actually works. Okay, so we go with 39/12 times t squared minus 7/3 times t cubed plus 1/12 times t to the 6th Ooh. Hang on. We said this was... Man. Y double prime minus 4/t times y prime plus 6 6/t squared times y is equal to t, where y at 1 equals 1, y prime at 1 equals 0. Solution. Yeah, it's getting a log in there. Man. Nah, it doesn't know what I'm asking. Cool. It really doesn't know what I'm asking. Okay, cool. Screw it then. Okay. So, I'm wondering if the same logic is applying for when we have two linearly dependent solutions, right? So like if we just look at if y were equal to, you know, for homogeneous, we get a characteristic with a doubled root. So like c1 e to the 2t plus c2 e to the 2t isn't going to work because you need to have two linearly independent solutions for a 2-space. So what do? We said, okay, well, if that's the case, we're just going to multiply this one by t to make sure that it's linearly independent. Right? So multiply this in. I'm wondering if this one is going to be the same, where y homogeneous got us this c1t squared plus c2 t to the third, and then since we needed to have, we want y particular to be t cubed, but we can't have it. So therefore, now I have no idea if this is true. But I'm wondering if this is saying, okay, similarly to how we did it before, we can't multiply by the same number because that would get us a different characteristic. But if we end up taking this one and saying, okay, let the root in question, or the characteristic in question, now be t cubed times the natural log of t, because this is going to be acting similarly-ish to how this one, we took an exponential and then multiplied the outside of the exponential by a linear function. So now we're taking a polynomial function and multiplying by what's the inverse of a, you know, not even inverse necessarily, but like the kernel of the equation was an exponential, and then we took a linear function, multiplied. Now the kernel is a polynomial, or like it's not in an exponential, so then we can multiply by a opposite of exponential logarithm. So I don't know. I mean, yes, it has to be that, right? Because we've exhausted all other options. I would suggest also take this to your teacher and be like, so what happened here? Like, why doesn't variation of parameters work for this particular problem? Because this is what I got, and it's linearly independent, and it does work when we start bringing these things all in together. So like, what's happening with all of this, and why doesn't it work to get us an acceptable non-homogeneous solution? I'm pretty sure I've never actually done this kind of thing before. But hey. Okay, so then y prime is going to be 3t squared times natural log t plus 1 over t times t cubed is just going to be t squared. We could even make that t squared times 3 natural log t plus 1. Y double prime is going to be equal to, this is going to be 2t times that constant. Oh, that's not a constant. Sorry, that function. And then add to it. Leave t squared. Multiply by, this is going to be 3 over t. Then we're done. So I think in this particular case, it's basically just adding an extra term onto it to like stabilize the whole rest of the equation. I don't know exactly how this works, but seems right. So just remind yourself, right, when you multiply or when you take derivatives of whatever you've got, what's going to get you at least part of the above equations? So in the case that we have here, you notice that we're also going to be plugging in y at 1. It causes natural log to go to 0. Yeah, so you can try looking for specifically a function that is going to, 1, derive back to polynomials, and 2, end up working with whatever your initial values are to just make zeros for that particular function. So let's see, this is going to be 6t natural log t plus 2t plus 3t minus 4 over t times t squared 3 natural log t plus 1 plus 6 t cubed natural log t. Boo. Alright. 6t natural log t plus 5t minus, this is going to be a negative 12 t natural log t. Oh, huh. And it might actually just go away. Minus 4 over t. It's still going to be 1. Plus 6 t cubed natural log t is equal to t when it all gets combined. Okay, so this is 6t natural log t minus 12t natural log t is going to be at minus 6t natural log t plus 5t minus 4 over t plus 6t cubed natural log t is equal to t. Should have been a constant in there, but it's going to be on everything, so it would just drop out. Not sure exactly how that works. Good evening and welcome, everybody. Over from Don Does Math. How are we doing this evening? My name is Obi-Wan Pez. This is N Simplex Pachinko, those of you who have not been here before. I have got all my stuff all my stuff in England now, and it is 2 a.m. Woo! I will probably not be doing this for very much longer. We were working on a differential equation, and it may have gotten a little out of hand. Just slightly, it's fine. So I think everything, like literally everything, has just an A value attached to all of it. And that would mean that the entire left-hand side has an A value. Yeah, thanks for coming on over. So this is going to mean that... So yeah, we want the particular to be t cubed. We can't do it, so we have to escalate it to t cubed natural log t. Then in theory this has an a value multiplied onto it, which is just going to carry through all of its individual derivatives. Which then is going to carry through all of the rest of the stuff all the way down the page. Till we get to here where A is going to be like multiplied by the entire left-hand side, and then the entire right-hand side is just T, meaning that we could solve for A, but now it's going to be really gross. And this should work for all t values, but I don't think it will. It's like this is going to have to get rid of a whole bunch of stuff. Nope, I'm in the north. So we are, broadly speaking, in Yorkshire, which is one of the fairly large counties up in that region of England, and they're especially known for their teas. They have several importers who get their stuff from London, but they bring it up to Yorkshire and then make Yorkshire tea and their own line in, what is it, Taylor's? I think it's Taylor's of Harrogate. So there's a bunch of towns. So we got Leeds is sort of like one of the big cities that's here. Then York is up this way, and then you've got that tea town, Harrogate, is just north of that. And then Manchester is like way down here. Glasgow's that way. Edinburgh is sort of north, slightly east, and London is approximately equidistant by train south. So 2.5 hours, give or take, from like the Leeds area. Yeah. Meh. I'm just saying geography words, like... Yeah, we got ourselves a P.O. box. We got all sorts of good stuff. The P.O. box, by the way, is American. So people can send things, or my family especially, can send things through the mail, and like all of our kids' friends have started sending like letters and postcards and things like that. So it's really nice. They just pop it in the mail, and it shows up here like, you know, several weeks later, whenever they get around to it. You know, if there's a bag of airmail for you know, U.S. military or something like that, they'll make sure that we get ours too. So it's pretty nice. So it's kind of interesting. There's a lot of stuff here that is significantly more and also significantly less expensive than the United States. And it's just, I don't know. I've only been here for 3 weeks, so like whatever, but yeah, there's just a lot of stuff that's like, I look at the price and I'm like, really? The last several times I've gone grocery shopping, it's been like, now granted, the amount I purchase is also smaller, but per month, instead of spending $200 on groceries, so far it's been about it's been about 150 pounds, and we're almost done with the month. So like every time I'm there, I feel like I'm paying more, but at the same time I'm maybe not actually. Yes, that's the other thing, is you don't tip, but at the same time you may have to pay a little extra. So like, I'm okay with it. Student protests, I have heard of something, but like, yeah, no, they're like, so I go to a coffee shop fairly regularly, and you know, they bring out the little pad, and it's the same pad and the same software that they use in the US. So like, you know, I go to tap the thing and it says, do you want to add a tip? And the guys at the coffee shop actually just tap the button a bunch of times until it escapes right out of it, because they're like, nah, it's not us. And I was like, on one hand, awesome. On the other, is that also encouraging perhaps people to see it and then realize, ah, well, now I can just toss my like loose change in the bowl. Extra couple of pounds or whatever, you know, coins, make my pockets lighter, that sort of thing. Oh. Freeing Hong Kong? Oh. Nope. Okay. I mean, they've got to have a reason to be protesting in the first place, right? Palestinian. Yeah, okay. Columbia University. $282 arrests. Wow. Yeah. So I mean, they're might be some, but says here, The Guardian says UK students begin a new wave of protests against Gaza war after the US arrests. So that's the other thing, is that a lot of the people over here are perhaps slightly less violent in their protestation, or at least the police have a lot lower response at the beginning. They'll try to move people along nicely a lot more and not jump straight to spray them with tear gas or pepper spray and all sorts of stuff. Mm-hmm. Yep. The University of Bristol released a protesting legally and freedom of speech page to make sure everybody actually understands what their limits of their rights are in the UK. Particularly, I imagine, students who have come from the United States. We're kind of stuck on this one here, just 'cause. So if we go with this, right, this should mean that we can find A by then plugging in the value. And just saying, okay, this is going to be A of, well, no, not quite. No, it's got to be added to all of it. Right. That's what I was attempting to do here in the first place. Okay. Jeez, man. All right. Yeah. All right. So just screw it. Let's go back to the beginning here. We say that y in total should be now C1 plus, no, C1t squared plus C2t cubed plus a t squared natural log t, t cubed natural log t, I don't remember, what did I say? T cubed natural log t. Which y at 1 should be 1. C1 plus C2 plus A is 0. So that's going to be gone. Which means that C1 plus C2 is going to be equal to 1. Yeah, y of 1 equals 1 was the initial condition from way earlier. Is it? Oh, man. I thought y1 was 1 and y prime of 1 was 0. Well, I want it. Jeez. Is that the reason that this one went off the wire or off the rails? Maybe. I mean, there was another reason why it didn't work, but... Alright, there we go. Nah, no worries. Alright, so y prime at 1 is going to be 1. And y prime is going to be 2c1. T is 1, so that's gone. Plus 3. c2, t squared is 1. Plus 3a. T squared natural log t. Plus a t cubed times natural log of t, take the derivative, it's 1 over t. So that's a t squared is all equal to 1. Right, so natural log of t, where t is 1, is going to go to 0. And then over here, this is all just 1. So a plus this stuff is equal to 1. Interesting. Okay. This is not going to come out with a solution. Ugh. So we got c1 plus c2 is equal to 0, and 2c1 plus 3c2 plus a is equal to 1. Alright. C1 and C2 are related to each other by... They're the same number, just one is opposite the other. Ow. Alright. I gotta stop. I've been hunched over, or not having a back. Alrighty. And Y839, I don't have anything to lift at this point, so I'm just going to refund you your Dostawin hoist, and I will lift weights some other time. Probably once I find them. No, they're going to be in the household goods shipment. I have some heavy stuff over there. I'll lift it next time. So, oh, there we go. I can do it over here. Yeah. Do. Refund points. There you go. Okay. So apologies for not getting that done, but we'll do it another time. We will pop over and see Belint doing some... What day is it? Thursday? Or Wednesday night? Well, sciencey stuff anyway. So, oof, I'll see you all later. We'll be back probably playing games on Friday. We'll see how it goes. And I'll try and maybe work on creating a better throne or something over here so I don't hurt my shoulders. At any rate, hope you all have fun. My name is Obi-Wan Pez. This is N Simplex Pachinko. We'll move on here, but thank you so much everybody for coming. And yeah, have a good rest of your week. See you later.